Hello, my name is Corey Lyman, 000-475-1016. The class is GDN 349-0. Section is C20180502. Um, this is my tic-tac-toe game. I apologize for not having the coding before. Um, Here we start off with, this is a background script I was going to work on for a rotating background for the gameplay. Um, I haven't started it yet. This is the exit screen. This was the only one that I got help with. I went to the Unity just to get my escape key. I've forgotten how to do the application quit. This is actually attached to the final scene, which is the end scene, and I just have it attached to a scene manager here, so that way this person can press escape to quit. Um, these are I I couldn't really think of another name for these, um, but this is what happens when the X's and O's drop on the screen. It is going to when the object is dropped here, it is talking to the main camera where I attached the script in the main game scene. Because of this game being in its simpleness, it really didn't need um, a game manager of any kind, because it's just one screen, one thing. There's nothing falling, there's nothing dropping, there's no gravity. So it grabs the camera component here, and that's when it spawns the game object um, on the mouse click. Um, Before I get to the logic, this is the scene manager for um, any of the X's O scenes, like play again, yes, no. This controls if yes, scene manager, load scene, using Unity and its engine scene management. We learned this in one of our earlier coding classes, and I just liked how clean the scene manager works. Same thing for this one here. Um, we've got the escape key, which is application quit, and then this is when they press. This is the one that I couldn't get to work, so I had to attach the exit screen script to it. This is the main. This is the main scene for when you are in the intro screen. You can do the scene manager load scene again with the scene management. Press spacebar, move on to the game screen. Um, so we'll open the game screen back up. Now, this is scripting. This is just a simple script, and this is just so as you can see, each space on the board has its general position, and they are marked up here to what position they are. Each one has a spot and a number attached, and this just tells, hey, public int square number, which is a number, is just telling that, hey, if I attach a number to this one, it's going to correspond to one of the squares over here. And as you can see with the main camera, it had generated. We'll get to this part here where it happens, because as you can see all right now it shows 0, but as they click on them, for this, you will see the squares disappear here, and you will see these numbers populate. So when you click here, the numbers populate over here, and then it changes over here to show you what goes where and what squares are remaining. And as there's no. Okay. Now we get into the logic script. I'll open this one up here. this logic script is, it looks more complicated than it is, only because of the win conditions. It's really is fairly simple. Um, it is used. It's basically how the game tells itself to what the different objects are in the game, where they're supposed to go, what they're supposed to interact with. Um, so as you can see, when you bring up, if you were to bring up this, we'll go to the main camera. Here we've got, this is the script itself. This is the green, which is attached to the script, the object itself in the prefab of the X and O, green and purple. Green and purple. This tells which scene to go to if X wins, this what scene to go to if O wins, what scene to go to if there's a tie. There is a simple and small canvas that I had to use only so that way the player knows which is the, whose turn it is to move. This main camera is the only thing that references that text. Nothing else on the canvas is scripted because it doesn't need to be. So here's your public values here. Now this public enum seed, it tells turn as to what series that it needs to move to in order to get through each possible thing. The public text instructions, which is what references the text in the on the canvas itself. So that's how I got this instruction text here. Now, for the identifier to help the game to notice the amount of squares, I had to use a new int for this here, and then squares equals new int 9, meaning that there are 9 elements there are 9 squares on the board. And then this tells that it starts at turn 1, and this right here keeps track of the count of the number of clicks that are made. This is only used mainly here at the bottom of the win conditions, so that way it knows, hey, if none of these conditions exist here, but you've clicked 9 times, then it's going to go to the tie screen. Here we've got the square int square number, which up here you can see the squares, and then clicked is going to reference the mouse, and it says int square number equals square dot get component dot cm spot square number, and this is going to tell the game itself which square is being clicked, and then it references the spot, changes the number, and then goes to clicked +1, and then changes turn. Now during these clicked, it's going to keep track at all times to see when the win condition is going to hit. Now, this public void spawn here just tells the game, okay, if it's turn 1, then we're going to spawn, a purple O, and if the purple O, sorry, I've read that wrong. Okay, so if turn 1, which is the game that it starts, then it's going to do the purple, which is the O, and then it moves on to turn 2. If it is turn 1, and it goes on to turn 2, then you want to instantiate the green, and then it goes back to turn 1. There again here, real simple, real easy stuff. And then here's your win conditions to keep track of. This is square 0, as all these squares are numbered, 0, 1, 2, which references these 3 squares, 0, 1, 2. If all 3 of those have an O in them or turn 1, then it will trigger the win condition. There are 9 win conditions per side, and it was just a matter of generating those 9 conditions and then having them load the appropriate screen. Thank you.